Okay, so let me just share to you my um, PowerPoint presentation. So hopefully you're okay. So last time we defined your Z transform, no, which is basically a special uh, transformation that is used to convert your linear constant coefficient differential equation or CDE into a different domain. So aside from a time domain into a different domain. So the concept is very much similar to, as I mentioned, Laplace transform. In order to do that and convert that into a different domain, this is the main formula for your Z transform, which is very much similar to your fast Fourier transform o yung Fourier transform mo, no? So ayan, again, you will see this, no? This is the exact, except that uh, uh, instead of e raised to negative s of t, z raised to negative n ang ginamit natin. Kasi since s there is a complex conjugate on your Laplace, dito naman, uh, e raised to negative j omega. So yung zn natin, ito siya. Okay? Ito naman yung form ng z transform natin. Okay? Um, and last time, I've shown you that the important parameter on your z transform would be the poles and zeros. Okay? The poles are the values of z that makes the function infinite. Okay? Whereas the zeros are the values of z's that makes your function value 0. Okay? So, and then you plot them on your z-plane with reference to your unit circle. Okay? O, yun siya. Basically like that. And then we've learned that there are 3 possible regions of convergence when doing Z transform. Okay? One is, sabi, what you call a right-handed sequence, meaning if the values of my sequences are on the right, nasa kanan lahat, okay? Kunyari yung mga input signals ko nasa kanan, are on the right of my zeros, then you end up with a convergence like this. All values at the exterior of the circle. Yun ang convergence mo. Okay? All values at the exterior of your circle. The circle is formed in reference to your alpha. Okay? So yun yung radius ng circle mo, yung alpha. It may not be equal to 1, but all values outside that circle is your region of convergence. The other region of convergence is all values inside your circle. This is for the left-handed sequence naman. So this means that if the sequence or the given signals are on the left side, ano ba yung left side? Negative n, di ba? Okay. Kapag ka negative n daw, yung sequence natin, automatically the region of convergence there would be all values inside your circle. Again, this may be smaller than a unit circle. The value there would be beta naman. Okay? And ano yung special case natin if ever we ended up with ganito, no? Which is in between, lumalabas. Okay? Finite length of sequence. Okay? Tapos, merong nasa left, merong nasa right yung sequence. Ako ba? Paano yun? Ano yung region of convergence nun? Pag meron ako signal sa right nung 0, meron pa akong signal sa left nung 0, paano yung region of convergence ko? Yung region of convergence mo would look like a ring. Like this. Okay? Whereby the region of convergence would be in the boundaries of your alpha and beta. Okay? Nasa in-between yung alpha and beta. Okay? So, ganun siya. And I've shown you, dito na lang tayo mag-continue. I've shown you the table of common transforms, which I simply cut off from the book. The table of common transforms for different signals. And we've seen that the transformation, Z transform, is basically the same, ito yun, para dito at dito. Okay? You will notice that, sir, ito rin parehas. Nakita ba? Okay? So, paano ko marirecognize yan? Magkaiba kasi yung region of convergence yan. Yung isa left-sided, yung isa right-sided. Yun yung point doon. So, kapag right-sided, anong term natin? Lahat ng exterior ng circle is your region of convergence. Ano ba? Pagka left-sided, the entire circle becomes your region of convergence. Okay. And again, we'll see that here. You could basically directly apply the form on a given finite duration of signals like this. So what would be our Z transform there? And take note, the region of convergence would be the entire plane except, okay, Z at 0. Bakit? There are limited elements found within your data signal. What about this? So both, ano to, merong left hand, may right hand. So the region of convergence would now fall in between a given particular value. Okay, again here, parehas lang yung kanina. Kasi ito ay right-handed. Entire plane except 0. Ito again, dual-sided. So, ano mangyari in between uli yan? And I'm showing you the region of convergence, how it's bounded last time. I've even showed you what would be the Z transform for a unit sample. Okay? So, ang Z transform lang niya is simply equal to 1. Okay? If you apply that into the formula. And the region of convergence would be everywhere in the plane. So here, I've shown you how the Z transform for alpha raised to n take note that the value alpha here would be a value between 0 and 1. Okay? Kasi dapat magko-converge. So dapat exponentially decreasing. Ayan siya. And I've shown you how this is equivalent to this. Parang 1 minus a. Ito yung sinabi ko na parang 1 minus a, no? Yung tinuro ko dati. Diba? Parang 1 minus a. Diba? Tapos dito, summation ng a. A plus a squared plus a cube plus a. Ganyan. Nasandaan? Paano naging ganyan? Oh, technically, ito yung a ko eh. No? It's like this value of a. Hindi yun eh. A. Diba? Summation 1. So summation yan, parang ganito. Diba? O yan, pinakita how we came about with that summation point. Kasi nasa table na yan, no? Baka parang sabihin ni sir, tinanggap na ni sir, ganyan lang yan. Okay? So hindi, no? Basically, yung derivation yan is as simple as that. So therefore, lumalabas sa ating conversion ng Z transform. It's a polynomial parate, no? That is expressed in terms of Z. Ganun parati yung Z transform. Okay? This would be the pole zero diagram for that given particular region. And I mentioned the similarity of that to your discrete time Fourier transform. And I've shown you this time yung negative naman. Ito yung kabaliktaran naman. So, ang ginawa natin dito is that we flip this, folded, and then we shifted it. Okay? Tapos, hindi ito magko-converge, kailangan negative negative alpha raising. Again, negative alpha there is a value between, yung alpha mo is a value between 0 and 1. Okay? Negative siya, ibig sabihin nakababa. No? Baligtad. Hindi sa taas. No? Okay? Nakabaligtad siya. And it's exponentially decreasing ulit. Parang ganyan, no? Yung mga stick natin. Okay? O ganun lang ibig sabihin. No? So technically, since it falls on the left side of your uh, Z-plane, lumalabas anticausal siya talaga. Like this. No? Nasa left side kasi siya. And again, that will converge. No? So if we transform then the sequence using the table, ito lalabas sa atin, which is exactly the same as your sum. Ito yung region of convergence and inside. No? Notice smaller siya ng unit circle. Yung alpha ang basihan natin dito. No? The value of the alpha. Okay? And again, ito yung advantage ng Z transform. That particular type of function does not exist for your discrete time Fourier transform. Therefore, you cannot convert that into Fourier. Hindi mo siya mako-convert sa Fourier. Nakuha kasi there is no equivalent ng DF doon sa table ng discrete time Fourier transform. No? There's no equivalent of that. Okay? So if we then try to compare the transforms of the signals, you will see that they're exactly the same, differing only on the regions of convergence. Therefore, ibig sabihin lang nun, Z transforms of a sequence is not uniquely defined. So ito yung we've shown this last time. Okay. Exponentially decreasing ulit ito. So magko-converge siya. So, and we've shown how to evaluate the Z transform. Ayan na. That's the first part. Kasi dalawa yung signal, therefore the second signal ay ito pala yung dalawa. Yung 1/2 kagagawa lang natin kanina. Kasi kakikita nyo lang kanina kung ano yung Z-transform. So basically, we just copy that and follow it here. Okay, ito nga yung nagiging limit mo, no? For your Z-transform. Okay, notice that it's exactly the same ulit yung Z-transform natin. Except that, ang region of convergence nito iba. So magiging ring yung region of convergence nito. So alpha is between 1/2, yung Z natin is between 1/2 to 2. This was the transform for the first term. This was the transform for the second term. Ganun lang. And you could simplify that. Pwede yung pang i-simplify if you want. Ito ngayon yung summary ng region of convergence na binabanggit ko sa inyo. So, kapag right-sided na exponentially decreasing, the signal would be the entire Z-plane except Z equal to 0. Ito yung summary na. Ito pa. Okay, ano yung mga properties ng Z-transform that we need to look into? The first one is linearity. Again, much like your linear time invariant systems on your discrete time signals, usually when you apply Z-transform, it has to be linear. It has to be time invariant. And again, it has to be non time time invariant, meaning it can be shifted. Okay, it's not affected by your time scale, or in this case n. So ito yung region of convergence na nag-intersect sila. Whatever portion they intersected in, that will be considered as the region of convergence. O yun yun. Kunwari, yung isa right-sided, yung isa left-sided. O diba? Ano yun? Yung isa kunwari, yung isa kunwari ay left-sided. So ano yun? Interior ng circle, di ba? So lahat ng ito. Tama. Meron na namang another signal. Ano naman siya? Mas maliit. Okay? Pero, ano siya, right-sided naman siya. So, kung saan nag-intersect yung dalawang region na yun, remember, kung left-sided siya, exterior ng circle. So, lahat naman ng ito, palitan natin ng kulay. Lahat naman nito, oops, lahat ito yung region of convergence niya. Di ba? Ayan. O, kung saan daw nag-intersect yan, yung blue tsaka yung red, yun daw yung region of convergence and it becomes a ring. No? Kung napansin nyo. So, asan dyan yung may dalawang color ng red tsaka blue? Nasang part yun. Di ba? So, pakita lang natin. No? Kung nasang part yun. Eh, maganda. Green na lang. Oh, nangyari yung pen yung nilagay ko. Naging eraser. Etong green na to, tsaka tong green na to, dun lang nag-intersect sa loob niyan. So, nagiging ring talaga. No? So, intersection talaga. Ganun siya. As dictated here, no? It's the intersection. O, that is if dalawa yung ano, no? Dalawa yung signal. Ina-add lang yung mga terms. So, dalawa yung region of convergence. Tapos, kung saan nag-overlap, ganun lang yun. Okay? So, kung parehong exterior yun, eh, di ganun lang yun kung sino yung mas malaki. Sino pala yung mas maliit? So, kunwari, ganito. Paano, sir, kung parehong right-sided? So, kung parehong right-sided, parehong external ng circle. Yes, correct. Eh, paano yun, sir? Dalawa yung magkaibang radius ng circle. Oh, so paano gagawin ko? So, ganito lang. So, meron kang first signal. Tapos, external niyan. Diba? Kasi right-sided. Eh, nagkaroon ka ng another circle. Let's say, naka-red. Eh, mas maliit siya. Eh, right-sided din siya. External ulit. O, di ganun lang ulit. Ayan. Kung external uli yan, mas madali ulit. Lumiit lang lalo. Diba? Yung hindi included sa region of convergence. Diba? So, okay lang kahit kung parehong external, kung parehong right-sided yung sequence. No? Tapos inad mo, tapos you want to get the Z transform of that, asan yung region of convergence yung dalawang signal na yun, sir? Ayan. Nakuha ba? It's always the intersection. Ganun parati siya. That's the concept whenever you have two signals. Then you have the shifting property. So dapat daw shift invariant when doing Z transform. Okay? So which means that dapat the value will not change regardless whether you shift it to the left or shift it to the right. Okay? So pag sinabing shifting property, dapat shifting should not affect the summability of the value. Therefore, shifting does not change your region of convergence. Hindi mababago yung region of convergence no, kahit shift. Okay? Pag nagdagdag ka lang ng points, may iba yung included na 0, na z equal to 0 o z equal to alpha. Yun lang. No? Kasi possible na ma-include sila or ma-exclude. Depende sa value. No? It all depends on the values in your signal. What else? Time reversal. Ito yung parang yung dito sa left side, reverse. Okay? Yung negative n. O yun. Okay? Pagka, when I fold it, it becomes negative n. So, mapupunta lahat sa negative side yung signal ko. So, again, dapat allowed yun sa Z transform. Dapat nare-reverse talaga yung time. So, again, wala namang problem yun kung mabaliktad siya, ma-fold siya. okay lang. Which means if that is foldable, parang gano'n, pwede palang i-fold. Ibig sabihin, magagawa ko rin pala yung convolution theorem sa Z-transform. Yes, you could also perform that process. Kasi remember, when you do convolution, you fold one signal. And then what? Uh, After folding one signal, you tend to shift it, di ba? O, ayun. So, allowed naman pala mag-fold sa Z-transform. So, ibig sabihin, you could also do convolution here, which, again, I will show you and show you a sample of the MATLAB code that is applied for convolution. Meaning, convolution is readily evaluated. Parang calculator lang yung MATLAB, no? Parang, di ba, I told you, we could treat the MATLAB like a direct calculator. Makukuha ka agad natin yung values. O yun, you could do that, no, for convolution processes. But of course, you have to learn where the zero mark is. No? Kailangan alam mo nasan yung zero kasi mamamali ka ng interpretation ng signal. Okay? Pagka may values na lalabas, pagka mali interpretation mo, mali answer mo lalabas. Nakuha ba? O yun, papakita natin yung later. Multiplication by exponential, this is multiplying it by a raised to n. Yun. Pero ang condition dito, no, that your alpha or a must be between 0 and 1 para mag-converge. So pwede pa rin daw yan. So basically, corresponds to the scaling of your z-plane. Parang ganun. And the region of convergence now becomes equivalent to your, meron kang left border tsaka right border ng region of convergence. Multiplication by exponential also shows that when you multiply a complex exponential, showing you that this is, again, similar to your Fourier transform. Parehong daw. Okay? Tapos, ang kinaganda niyan, you can now analyze that region of convergence that your Fourier transform cannot analyze. Okay? Hindi niya ma-analyze. Nagagawa mo na ngayon sa Z-transform. Okay? Nagro-rotate lang kasi yung sa Z-plane. So ito yung sinasabi ko, pwede palang mag-fold, pwede palang mag-shift, therefore pwede tayong mag-convolution. So again, convolution theorem is also defined onto your Z-transform. It's basically the multiplication of your signal. So again, this is not the actual multiplication lang. No? Parang ano siya. Take note, yung scalar multiplication sa MATLAB nyo is that asterisk. Okay? Yun yung scalar multiplication. Hindi ganoon yung ano, no? Yung convolution theorem. Asterisk lang siya talaga. Okay? So under convolution, ayun yun, yung asterisk. Again, meron kang basic signals. Actually, pwedeng both signals to, no? Pwedeng dalawang x yan. And I'm trying to get the convolution. Ganun pa rin yung formula. Hindi siya technically ano, no? Baka akala nyo impulse response H. Okay? Hindi kailangan parating impulse response H yun. Ano? Ang inaano ko sa X. Pwedeng dalawang signal ko convolution ko. Okay? Parehong dalawang X yun. Pwede yun. Ganyan pa rin yung formula. Exactly the same. Okay? Parehas lang yung formula. Okay? So, I think I have an example here regarding the convolution theorem. For the convolution theorem, the region of convergence of your y includes the intersection of your Rx and Ry. Again, yung intersection yan. Okay? Tapos, kasama yung pole and there's a possibility na magka-cancel yung pole and zero here. Okay? When you're doing convolution theorem for Z-transform. Okay? Possible yun. Eh? So, let's show that. No? Let's say I have two sequences. Ito. Meron akong xn tsaka meron akong response ng impulse response na ganyan. So the transform of x of n is like this. Kasi this was taken from the table. Alam na natin yan. No? Okay, paano yung h of n? The transform of your h of n is this. Okay? So paano ko nakuha yun? Yung delta signal, kapag ka-transform yan sa Laplace, sa Z-transform, is simply equal to 1. Nakuha ba? Ito is equal to z raised to negative 1 lang daw yan. Yan. Pagka ginawa mong Z-transform. Tapos multiply mo lang ng alpha. O yun na. Okay? Nakuha? So ito naman daw yung Z-transform nito. So, if I apply now the convolution theorem, ito daw, multiply ko yon kasi parang multiplication lang yung dalawa. So magka-cancel lang yan. Anong answer? 1. Correct yun. Nag-cancel yung ating pole and zero. Di ba? So possible yon. Okay? Ang anong region of convergence nito? Simply the entire z-plane na kaagad. Kasi nag-cancel yung poles and zeros. So just the entire z-plane. That's the region of convergence. Possible yan. Okay? So nangyayari yan in some cases sa Z-transform. So let's try to have like two signals. Paano kung dalawang signal na? Ano yung convolution nito? Ito yung sabi ko. No? Pwedeng dalawang signal yan. It's not the impulse response. Hindi H. Dalawang X. I have a signal of an X1 signal with a value of 1, -2, tsaka 1. Okay? So obviously, it meant dahil walang ano to, no? Walang arrow or underline, it simply means automatically that this is my n at 0. Ito na. N equal to 0. Ito n equal to 1, n equal to 2, etc. etc. Okay, dito naman sa pangalawang signal, okay, ang value daw nito ay 1 from 0 to 5. So parang ano yan, no? Unit step. Parang ganyan, 0 hanggang 5. Ang amplitude niyan parate 1. Okay? Ganun nangyari, no? Tapos 0 everywhere else. So 0 na lahat yan. So ito yung 0 marker mo. Okay? Or if you want, I could make this like sticks para maging discrete signal. Puro 1 yan. 1, 1, 1. 5 1. Parang ganun. Okay? 1, 2, 3, 4, 5. Puro 1. Hanggang 0 eh. Mula 0 eh. 6 pala. 6 na stick na 1. Starting from 0 all the way to 5. Okay? So ano yung convolution yan? So pakita natin. So the Z-transform of your first signal would be like this, and the Z-transform of your second signal would be given off like this. Okay? Pag kinonvert ko, anong ginawa ko? Direct transformation ng Z. Okay? Yun lang ginamit ko. Nakuha ba? Hindi ko ginamitan ng table yan. Direct Z transformation yan. Kasi discrete signals ito. Okay? Hindi siya infinite, no? Okay. Then, after that, oops. Tatanggalin ko lang yung annotation. Nakaharang. After that, we carry out the multiplication. So, technically, if I multiply that, ito yung magiging product. And if you do convolution, ito yung lalabas na output. Which is basically the same. No? Pag tinignan mo, pag multiply ko ba directly, ganun din lalabas? Yes. Yung dalawang signals, sir, yes. Yan, yung lalabas. If you multiply the two signals directly. Okay? And again, as I mentioned, you could do that in MATLAB. Kaya mong gawin sa MATLAB yan. The same result can also be done by noting parang ganyan, which is basically sinimplify lang ito. Okay? So, noted there that there was cancellation on your Z values. No? Ayan. So, eto ngayon yung final answer on your convolution. Okay? Which is basically, if you plot it, ganito lalabas. Kaplinat mo. And again, nilagay yung arrow there because n there is 0 at this value of 1. And as I mentioned, you could also do that using your MATLAB. So ito, ano bang ginawa ko rito? This one is a different example. Iba example naman ito. Again, ito yan. Those are the data values there. For X1 and X2 signal. And then if you apply convolution, ito yung MATLAB script. Ito, pinakita ko pala dito example. Ayan. So ano yung command for convolution? CONV, con. Okay? Tapos open parenthesis, lalagay mo yung first signal which is x1. That's the label, no? Comma, x2. That's the label for the second signal. So you just declare them. I-declare mo lang yung signals first. Yung mga values dun sa signals. Take note of the notation. Dapat ganyan siya. Automatic n at 0 dito. N at 0 dito. Nakuha ba? Kung hindi, malilito ka. Otherwise, dagdagan mo ng 0. Ganun lang yun, no? Okay? Eh, sir, ano to eh? N at 2 to eh. Dapat itong 2. O di dagdagan mo ng 0, 0 dito sa harap. Lalabas yan, 2 na yan. Diba? Wala naman palang value doon sa ibang part eh. 0 lang. Diba? O lagay mo lang ganun para hindi ka nalilito. Kasi ang default ni MATLAB, yung first term would be n equal to 0. Okay? So, ito yung answer na lumabas. 6, 17, 34, 43, 38. So, how do we interpret that? Ayan. So, 6 would be the value for n at 0. 17 would be the value at n equal to 1, and so on and so forth. So, ganito ngayon yung Z-transforming, yung convolution, which is referred to as X3. Noted as X3, no? Dun sa ating system. Nakuha? How easy you do convolution. Ganun din na pagka nag-ano ka. Yung dating activity last, basically activity, I think it's activity 4. Meron dong convolution. There, you could do that. On the convolution process, no? Using the MATLAB script. Actually, mas mabilis to if you do this. You just need to know how to interpret these output values. No? Automatic at n equal to 0 yan. Okay, ganun siya. You could also multiply two z-domain polynomials even if they are non-causal sequences. So ito ay non-causal. Nasa left side ito, no? Kaya sinabing non-causal. Wait lang, class. Okay, so continue, no? So you could also apply Z transform to a non-causal. Again, we could do convolution theorem for causal, no? Non-causal systems. Uh, it will not affect the process. No? Ganun pa rin. And we've shown that last time, no? When we were doing the 1Z technique na tinuro ko sa inyo for convolution, no? Yung 1Z technique. So, kasama yun, no? Okay. So, shown here. So again, these are non-causal values. Ganito ngayon yan, no? So meron tayong values sa left, meron tayong values sa right. Okay. So using the MATLAB again, ganyan siya. And you specify there the, ito, let me just show the annotation. Ito yung N for here. Nakuha ba? So showing that 2 there is the one at N equal to 0. Kasi negative 1 to 1. Tapos dito naman, negative 2 to 1. So this means this starts at N equal to negative 2. And this ends at N equal to 1. Nakuha ba? Okay. So, lalabas niya ngayon yung convolution value, which is this. At bibigay niya yung position ng N. N equal to negative 3, negative 2, negative 1. Ito yung N at 0 mo. Okay? N at 1 and N at 2. So when you write them, pag sinut ko ngayon yung Z transform nitong convolution na to, I'd end up with, okay, ganyan ngayon. Nakuha yan? Okay, so you could do that on MATLAB, no? Pwede. As shown here on the script, no? Huwag na natin i-try. Nakita nyo na yung answer. Okay, kayo na lang mag-try sa MATLAB. Ayun na nga, no? Okay. In passing, you could also perform the convolution. Okay? Which is the opposite of your convolution. Okay? Pwede rin yun. It's the inverse operation of your convolution. Tawag the convolution. And you could do that also in MATLAB. Okay? Meron din siyang command para doon. So, the whole concept means dividing one polynomial with another polynomial. Kasi remember, when you're doing convolution, it's like you're multiplying the polynomials, right? So therefore, it's a product. Para makuha ko yung one polynomial, out of the product, I'll simply divide that by the polynomial. Di ba? So, ganun ngayon siya. So, basically, parang polynomial division lang siya. Ganun lumalabas. On terms, the convolution. So, in MATLAB, you could also perform that. The command there is deconv. Okay? And then write down the value of B, yung result ng convolution natin sa B, and then divide that by your polynomial A. Okay? If there is a remainder, papakita naman niya sa inyo, may polynomial part, tapos may remainder part. Okay? If that is not exact. Okay? So, from the previous example, ito yun, na x3. Ito yung x1 natin, ito yung x2 natin, di ba? Okay? Ito yung una example. Okay. So, ito yung x3 natin. That's the answer. So, if we apply there the convolution, x3, ayun yung x3, dineclare. Ano yung x1, ayun dineclare. Tapos yung x2, comma, remainder, is equal to your deconvolution of x3. Okay, ganyan ngayon. So, he shows you the value of the convolution there with your remainders. Ganyan ngayon lalabas on your MATLAB. So on the MATLAB, you could perform both convolution and deconvolution. Okay? So again,
that process will be included, the convolution process will be included on your, kasi uh, dun sa lesson natin, lumalabas parang siya, module 2 siya, no? Yung convolution. Nandun siya sa module 2 nung lesson natin. So may include ngayon siya sa exam natin sa module 2. Along with your Z transform. Nako ba? By the way, you could also perform convolution on Puye. Pwede rin sa Puye. Papakita rin natin yun later, no? Okay? So convolution property is one of the most powerful properties on your Z transform because it converts your convolution of signals from a time domain, which is actually very difficult to do kapag ka naka-time domain. Pero pagdating ng Z domain, you just multiply the transforms. Okay? And basically, this is the steps that we're actually doing. No? So first, compute the Z transforms of the signals that are to be convolved. After that, okay, so parang ginawa mo na from time domain, ginawa mong Z domain. After that, multiply the two Z transform signals, naka Z domain, find the inverse Z transform of your, to turn back your Z domain to your time domain. Ganun lang. Nakuha? So this procedure, in many cases, is computationally easier to do rather than the direct evaluation of your convolution summation. Okay. Uh, Also, there's another property called conjugation, okay, for your Z transform. So basically, it's just the complex conjugate. Kaya ang tawag niya conjugation. Complex conjugate lang ito, no? Ganun lang, ibig sabihin. So, complex conjugate ng iyong transform. Lalabas siya. Okay? Kasi, note, pwede siyang e raised to j omega n, di ba? Therefore, pwede natin kuhanin yung complex conjugate nitong e raised to j omega by simply obtaining yung negative side naman. So basically ang term nila corollary. Okay? Oops, sorry. So ang notation doon is always asterisk. Yun yung ginagamit nila, no? Pag sinabing conjugation. Ibig sabihin conjugate ito no Z transform na to. Okay? Derivative, you could also convert or the Z transform of any particular derivative. Okay? So, paano daw yun? Ang conversion niyan is simply this equivalent uh, format of your Z transform. Okay? So, repeated application of this property allows your evaluation of the Z transform for any order of your derivations. Kunyari, second derivative, third derivative, fourth derivative, paulit-ulit lang daw. Ganyan lang daw yung process. So, if I summarize that property, lahat ng property natin, so you have the linearity, the shift, the time reversal, the exponential, the convolution, the conjugation, the derivative, and this is the common notation for the sequences there and their Z transforms. Plus, I've included here the summary for the region of convergence for each of this property, no? Okay? So kapag meron ka daw dalawang signal na ina-add, linearity yon. Ano daw yung convergence nun? Ano yung region of convergence? The intersection of those region of convergences. Yun, ano? Di ba? So a property that may be used to find the initial value of your causal sequence from the Z transform is the initial value theorem. So meron siyang initial value theorem just like your Laplace transform. Okay? So ito ay para ma-solve lang yung mga causal sequences. Okay? So of course, this property is a consequence of the fact that your x of n would be equal to 0 and there would be kapag ka less than 0, yung n wala nang value. 0 na. Okay? So hence, you'd end up with this form parate. Nakuha ba? So therefore, if we let z go on to all the way up to infinity, so ano lalabas? each term in your x of z goes to 0 except the first term. Okay? As it approaches infinity, no? So lahat ng term daw doon sa sequence magiging 0. Magiging 0 yan, magiging 0. Except ito. Nakuha ba? So yun yung concept, no? Yun yung consequence on habang nag-approach siya ng infinity. Okay. So that covers then the discussion for the Z transform. Actually, there are a few more examples that you could see regarding the Z transform on the video lesson. No? Nandun may example do sa video lesson. I think nandun din yung derivation, no? If you were able to watch that. Nakuha yan? Okay, so that would mean that on Friday, we could have the module 2 exam. So Friday, module 2 exam, tapos, kasi week 8 naman talaga yun, di ba? And then, siguro a makeup exam will be scheduled by 9th week na lang. Yung makeup exam natin. Okay? So the exam covers Z transform. Okay? Application ng Z transform doon sa discrete signals natin. Okay? And then, the whole concept of the convolution kasama. Okay? Anyway, yung convolution naman ng signal on the first part of the discussion is exactly the same convolution process here on Z transform. Parehong-pareho. Okay? Any question there?
Wala naman po, sir.
None po, sir.
Okay. So, I want you to turn on your cameras for a few seconds so you'll be recorded within our session. This serves as your attendance. I hope you're all feeling well and healthy pa rin. Please do not go out yet kasi malakas pa yung spread ng virus hanggang ngayon unless you are already vaccinated. Okay? Ang problem is hindi kayo libre. Sa vaccine. Ang libre na healthcare workers yan. Hindi tayo libre, no? Ibig sabihin, kailangan mag-avail tayo ng bakuna. Okay? Okay. So, nakabukas na yung camera ng lahat. Thank you very much, guys, for joining in our session. Thank you, thank you. Stay safe, stay healthy. Yes, you may log out of the session now. Thank you, guys.